Okay, welcome everyone. Welcome back. Happy Friday. Yay. As a reminder, as we are finishing off our assignment, there were makeups this morning for some people, but as awesome as you are, my two classes were totally present. Absolutely no outstanding, assignment pieces that were, they were all done on time. So amazing. Thank you. I could gloat in front of my other teachers, so that's all on you, not me. Monday, I will commit to giving it back to you so that you have something in hand while we finish off 3.4. So you're thinking, what do you mean finish off? We're doing 3.4 today? Yes, we're doing 3.4 today. It's going to be a light lesson, but since it's a light lesson, I'm going to throw something about inequalities that I think you should know, which explains to you why I told you never multiply the denominator on both sides to simplify an inequality. It's very dangerous, and I'll show you a very simple example. Question? No, but if you'd like, I can see what I can do in scanning it and putting it on Brightspace. Yeah, I'll see if I remember that. The review still incorporates 3.5, but it's a small piece, so maybe you'll be able to get it on. True, so you can sort of spread it out. Absolutely. I will. Mental notes. Where's my pen? Upload chapter 3 review sheet / questions on Brightspace. Okay. Hopefully this will remind me right on my phone. Okay, here we go. Very simple example. I'm going to do what most people will probably do because they are well versed in algebra. Okay? How do I solve for x? How do I isolate x? Well, first thing we do, either reverse BEDMAS or what I tell my grade 9 students, cover your x term, right? And what do you have on the outside? Work outside in. Don't laugh. That's actually what I do. Okay? If you cover that, you're only left with a -5. How do you get rid of a -5? +5 on both sides, right? So let's do algebra by adding 5 on both sides. And what do we get? -3x is greater than 5. Mathematically correct. And then how do you get rid of a multiplication of -3? Division. So if you divide both sides by a -3, you would think the answer is going to be x is greater than -5/3. That is, yes, that is incorrect. It's actually something else. The sign flips. Let me explain why. Let's do this again, pretending that this x is a 1, but you don't know that. Okay? You don't know it's a 1, but I'm going to sort of it's a mystery box. I'm going to put the 1 in there. We'll see what happens. Same as before, I add 5 on both sides. This is -3x is greater than 5. And then if I divide both sides by a -3, I have 1. Wait a minute. Oh, darn it. Let's make that a -1. That's the only way to make this work. Sorry. If I put in a -1, I will divide both sides by -3, giving me -5 over -3. Sorry, 5 over -3. So what you're saying is -1 is bigger than -1.6 repeating. Is that true? Yes, it is. What am I doing that's not proving my point? Wow. Give me a second. Is it because I have a bad example, or am I doing math wrong? +5. Good. Divide by -3, divide by -3. That should be x is greater than -5/3. Okay. But if I were to do the same thing, +5, divide by -3, divide by -3. I think I just chose a really terrible example. How about, you know what? I'm going to use this to my advantage, okay? This is not a mistake. This was intentional. If that was a -2, and that was a -2, and that was a -2, my answer would be -2 is greater than -1.6 repeating, and that's not true. Right? So by solving this, sometimes it works, and sometimes it does not work. That's not going to be helpful for us. When you are solving inequalities, okay, this ambiguity cannot exist. And so we test it. When you are plugging in a number and you are, okay, so let's start from scratch, okay? Because of that ambiguity, there is something more we have to get into when we're doing inequalities. If what we are dividing or multiplying on both sides is a negative, it is a established rule that you have to flip the inequality. Okay? Another way we can talk about it is think about it as a graph. There are times where we have positive and times where we have negative. If you were to take this graph and multiply or divide by a negative, you get the complete opposite of what we initially had in terms of plus and minus signs. I'm not sure if that's a good example or not, but long story short, let's consider this situation right here. 4 over x minus 3, 4 over x minus 3 is less than 2. If I were to multiply both sides by x minus 3, you are supposed to get 4 is less than 2 bracket x minus 3. How do you know if this is a negative number or a positive number? You don't. So what do you have to do? You need to do 2 different cases, which is really annoying. You know what you'd have to do? You'd have to say, case 1, you don't have to write this, but case 1, if x minus 3 is greater than 0, then 4 is less than 2 times x minus 3. Then you'd have to do case 2, if x minus 3 is less than 0, then 4 is greater than 2x minus 3. You would have to do 2 questions instead of 1. Really annoying. It's not something I want to get into. And the only time I think this is necessary is if you go to university and you deal with something called absolute values, absolute functions, where you don't know if the inside is positive or negative, right? And so let's not ever multiply denominators to both sides. You will have to do 2 questions instead of 1, okay? So anytime you deal with inequalities or even equations, please don't multiply the denominator, only bring everything to one side, make it all equal to a 0. Okay? Hope I sort of made an argument. Sorry about this messiness. I should have thought about a good example. Here we go. Example 1, we are going into, as you might have noticed, inequalities. And graphically, when is this green function greater than or equal to 0? I hope by now you can say it's going to be all of this and all of that and all of that, which means it goes from negative infinity to a -4, including -4. It goes from 2 to 5, includes a 2, but does not include a 5, because it's an asymptote. And then from 6 to infinity, includes a 6, and infinity, you know how to deal with that. So the answer for this would be f of x is greater than or equal to 0 when x belongs to, I'll do an interval. Let's see, curved bracket, negative infinity, comma, -4 with a square bracket, union, square bracket 2 with a 5 curved bracket, union, square bracket 6, and curved bracket infinity. And x is 75. For my afternoon class, I'm going to have to think of a better example so I don't confuse them. Sorry about that. So, which means, what are we just simply testing here? Does that look familiar? When have we ever done that for disagreement? Above or below? When have we ever done that for disagreement? Yeah, when you're testing, right? But when you're testing horizontal asymptotes, you would be testing this one line. What I'm doing is testing whether it's above or below the x-axis, where the x-intercepts by intervals. Okay? So for this part of the lesson, it's something you've already done before. You're only checking intervals. Welcome. So here we go. Let's solve. As always, I am going to bring everything to one side by subtracting the 2. Please turn this, and let's see, this is sort of like your homework check. Please turn this into a single fraction and then solve intervals. See what you can do. Okay? I'll give you like 3 to 5 minutes, see whatever it is, and I'll pause the video so that the people don't have to wait. All right, let's get started. If you got a chance to work through this, you would see 4x minus 3 minus 2x minus 3 with another x minus 3. I hope this is very clear. You're multiplying by a 1, right? So it's legal. Next, since I need to turn that into a single fraction, it makes my life so much easier, and I could use so many rational function tools that we learned by doing so. I have -2x positive 6. I hope no one got mixed up with that. It is a positive 6. And that turns into -2x plus 10. Okay. How do we know it's no longer equals? Because if it was equals, we just look at the numerator. But since it is now an inequality, we need to see when is it above a 0 and when is it below a 0. Here's where your interval chart comes in. From here, I would say, I'm gonna factor it. It's easier to deal with a single coefficient of 1 instead of anything else. Okay, and so test signs. As a sign chart, we have -2 will always make it a negative. X minus 5 could change signs. X minus 3 could change signs. So there. What do I place in the upper column, upper right column? As a reminder, I have to put in all vertical asymptotes and all x-intercepts. Yep. 3 is one of them, right? So we have vertical asymptote equals a 3. What is an x-intercept in this case? What makes the y value 0? Yeah. You see how the, VA, I should say x equals a 3 and x equals a 5. Seeing how your dysamic skills come in really handy. Right? It's immediate, and I love it. 3, 5. -2 will always be a negative, so that's not a big deal. but this is my VA. That is my 0. If the value of x is lower than 3, that's going to be a negative, and that's going to be a negative. So that's a negative. If the value of x is, let's say, a 4, that's going to be a negative, but that will be a positive. And if that is a 6, that's going to be a positive. That's going to be a positive, so it gives me a negative again. All right. Based on this, when is this new function less than 0, not equal to, but less than? Right there and right there, not including 0, not including. So therefore, 4 over x minus 3 is less than a 2 when x belongs to negative infinity to a 3, not including, union 5, not including, all the way to positive infinity. Inequalities. It's part of your dysamic. So being able to do dysamic, this is a very, it's like a snapshot of your analysis. So I hope instead of thinking of this as something completely new, just think of this as they're asking me for the same thing, but they're starting at a different location. They're starting at a certain point. They're only asking to see if it's plus or minus.
Which one? What other brackets, like the square and the round? Which one includes the value?
So the curve is not including. So seeing as how the infinities are always curved, maybe that will remind you. Since you can't include infinity and infinity is always curved, this is not including. Okay? And that's it. I could do more. I'm thinking I want to give you an opportunity. I feel like you really can get through this on your own just with a little bit of time. How about we do one more example? An example for example 3. We'll try it together. Example 4, the answer key is already found here. Okay, if you take a look at the sheet, the PDF, I don't have enough space. So it says answers on the next page, and I wrote it on a spare piece of paper. Okay, so hope that works for you. Notice how I do the entire analysis, but that's not necessary. All you have to do is figure out what the asymptotes are and what the x-intercepts are, because that's what we're going to need. And notice how the numbers are a little wonky. Don't be afraid of that. Okay, embrace it. Here we go. Example 3. I hope I do get a weird x-intercept for this one. It will help with practice. As always, please do not multiply the denominator to both sides. Instead, please bring all the terms to one side and make the other side equal to a 0. And as a kind of an olive branch, I'll do this part for you. To make the denominator the same, I will, in essence, multiply 1 and subtract it by x multiplied by, oh, this one has a denominator of 1, so I have to actually, oh, I'm sleeping. This is a 1. The denominator isn't a 1. I don't have to multiply this at all. It's in fact the other one that needs a multiplication. My bad. There. That's my bad. I'm sleeping. There. See what you got? I hope you'll be pleasantly surprised and you see how your grade 10 quadratic skills continue to pop up again and again. Let me pause the video and you can give this a shot. Yeah, as you can see, factoring is important. You could thank your grade 10 self for that, okay, for working so hard. So we have negative x squared minus x. Me? No, even I think it's gonna be a negative, so x minus 2. Yeah. So we've got x positive 3 and an x minus 2. Yeah. So we are ready for the chart. Oh, since we need it, vertical asymptote, x equals negative 2. X-intercepts, negative 3 and a 2. If you are not sure what to do here, you can always very quickly do your dysamic, and you will get all the pieces you need. But if you know through your practice that you're going to end up using just your vertical asymptote and x-intercept, you can go straight into that as well. Welcome. Hi. Absolutely. Only thing is, one of these will be a negative x, like a negative x minus 3 or a negative x plus 2. And you just have to watch out for that when you do your chart. I think it makes it more complicated. I would prefer that anyways. Yes, Ali?
It's kind of a similar question, but the way I did it, I didn't factor out the negative 1 as the deviation. And then that left me with x plus 2 and x minus 3 in the numerator, and then I crossed out x plus 2.
I see what you're saying. They're saying, if you leave the numerator inside, you see a plus 2 and a plus 2, so you want to cancel out. Please be careful. If that's the case, one of your x's should be a negative, which means they're actually not equivalent factors. It's very easy to sort of miss that because you're looking for something, right? Just be careful. So what are my, in numerical order, we have negative 3, negative 2, then a positive 2, and away we go. Minus, 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 and I should remind myself my negative 3 is a 0, my negative 2 is a VA, and my 2 is a 0. Negative, 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 positive, positive, negative, negative, negative. Positive, negative, positive, 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 positive. So we've got, when is this new function that we created greater than a 0? Well, it is greater than or equal to, it's all of that, including the 0. Not including the vertical asymptote, but including that 0 right there. So we have x plus 6 over x plus 2 is greater than or equal to the x itself when x belongs to negative infinity all the way to negative 3, including negative 3. Union, not including negative 2 because it's a vertical asymptote, but includes a 2 because that is the 0 and we're allowed to have zeros. End of question. So that's it. As a summary, when you're doing equalities or inequalities, please make sure you bring everything to one side. And if you turn it into a single fraction, you are able to use all the things that you've learned so far with disayment. So it's not like you have to learn anything new. You just continue to reinforce the tried and true analysis. Someone had a hand up, Remy?
If it's asking when it's just less than 0, not equal to, you would not include the
Correct. If it was just less than or just that, then I definitely wouldn't have drawn the x this big. It would be, can I not move this? Wow. It would just be, oh my gosh, my life. It would just be here. Because it doesn't include the 0. Does that make sense?
Yeah.
And also for this one, it would only be from -2 to +2, not including a +2. Right? A question? Yes, of course. Yep. Okay. Well, if you have a question, please, by all means. Last one, why not give it a shot before you go? We have about 20 minutes before our shortened period ends. I'll do the answer key here since I have some space, and I guess I could upload this as well. For the sake of you looking at my previous mention about not multiplying, let me clean this up a little bit and put it online so you can see it later as a reminder. Any questions? No? All right. Then that's it. Please use this